This video is the second part of the section 6.2 video for Math 95. In this part, we're going to look at 3 examples of adding or subtracting rational expressions. Here's our first example. We're being asked to do subtraction of a couple of rational expressions. Our first step is to find the least common denominator. I look at my 2 denominators and I notice that there's nothing there to factor. So all I need to do is write down my least common denominator. My first denominator has an x minus 5 in it, so I need an x minus 5. My second denominator has an x plus 5, so I'll need an x plus 5 for my least common denominator. My next step is to build up each fraction so that it has the least common denominator for its denominator. I'll start with x minus 1 over x minus 5. Now my goal denominator is x minus 5 times x plus 5. My fraction here is only missing the x plus 5 part, so I'll multiply the bottom by x plus 5. Of course, whatever I do to the denominator, I've got to do to the numerator as well, so I'll be multiplying the top by x plus 5 as well. Multiplying across, that gives me x minus 1 times x plus 5 all over x minus 5 times x plus 5. Now I'll take a look at my second fraction. I have x plus 2 over x plus 5. My goal denominator is x minus 5, x plus 5. In order to get this denominator to look like that one, I need another term of x minus 5. Now whatever I do to the bottom, I've got to do to the top of my fraction. So when I multiply across here, I end up with x plus 2 times x minus 5 on top, and x plus 5, x minus 5 on the bottom. Ultimately, I know that when I subtract these fractions, I'm going to need to multiply the numerators out so that I can combine like terms. So I'm going to go ahead and do that right now. Now I've built my 2 fractions up to have the same denominator, and I've also gone ahead and multiplied the numerators out so that when I do the subtraction, it will be easier to combine like terms in the numerator. Step 3 is to actually do this subtraction by subtracting the numerators, but leaving the denominator the same. I like to write this down again, just to help me stay organized. Now I subtract the numerators. So my first numerator is x squared plus 4x minus 5. I'm subtracting the second one, which means that the sign of all 3 terms is going to change. So I'll have a negative x squared plus 3x plus 10 all over that same common denominator that we found earlier. Now we've done the subtraction, but we can simplify this a little bit more. Notice that on top I've got lots of like terms that can be combined. X squared minus x squared is 0x squareds. I have a 4x plus 3, so that's a 7x. And then I have a negative 5 and a plus 10 for a plus 5 on top. My denominator just comes along for the ride, same denominator. Finally, I look at my new numerator and see if it's possible to factor it, just in case something might cancel with my denominator. Between 7x and 5, there's nothing in common, so my numerator can't be factored, there's nothing to cancel, and this is my final answer. For my second example, we have a couple of rational expressions to add together. Our first step is still to find the least common denominator. In this case, it looks like I'm going to need to factor these denominators in order to figure out what that least common denominator is. So I'll come over here with x squared minus 4, and notice that that can be factored as x plus 2, x minus 2. My other denominator is just x plus 2, which can't be factored any further. So my least common denominator will have all of the factors necessary to make up each of these 2 denominators. My first denominator needs an x plus 2 and also an x minus 2. My second denominator just needs an x plus 2, which I already have, so that means that this is actually my least common denominator. My next step is to build up each of my fractions to have that least common denominator. So my first fraction is 2x over x squared minus 4, but I already know that that factors as x plus 2, x minus 2. Notice that it already has my goal common denominator, so we don't need to do anything special to build that one up. It's already there. Now we'll take a look at my second one, which is 3 over x plus 2. Now this guy is missing something from the goal common denominator. My goal denominator is x plus 2 times x minus 2. And this guy is missing the x minus 2 part. So I'm going to multiply top and bottom by x minus 2, which gives me a new numerator of 3 times x minus 2 and my goal denominator. Now, just to clear things up a little bit, I'm going to go ahead and distribute that 3 before we move on. This is the same as 3x minus 6 over x plus 2 times x minus 2. My third step is to actually do this addition. I have 2x over x plus 2, x minus 2, plus 3x minus 6 over x plus 2, x minus 2. Notice that they have the same denominators, so all we need to do is add the numerators. 2x plus 3x minus 6 all over x plus 2, x minus 2. Now we have actually done the addition, but we can clean this up a little bit more. 2x plus 3x is 5x, and I still have a negative 6 here. And then my common denominator is still x plus 2, x minus 2. Now, before I circle my answer, I should go ahead and make sure that I can't simplify this any further. I look at my numerator, 5x minus 6, and notice that I can't factor anything out, which means that I won't be able to cancel with anything in the denominator. This really is my final, fully simplified answer. For our last example, we have another addition problem. Remember that our first step here is to find the least common denominator for our two rational expressions. To do that, we'll need to start by factoring each of the denominators. So I'm going to do that off to the side. X squared minus 2x plus 1 factors as x minus 1, x minus 1. And x squared minus 3x plus 2 factors as x minus 2, x minus 1. Now I'm going to write down my least common denominator. Remember that my least common denominator needs to have the factors required to make up each of my two denominators. My first denominator needs an x minus 1 and another x minus 1. So x minus 1 times x minus 1. Or we could write x minus 1 squared if we wanted to. Now my second denominator requires an x minus 2 and an x minus 1. I already have an x minus 1, so I don't need another. But I do need this x minus 2 piece. Now that I have my least common denominator, my next step is to build up each of my rational expressions to have that as its denominator. So I'll start with my first expression, which I already factored the denominator for, finding that it is 3 over x minus 1 times x minus 1. My goal denominator over here is x minus 1, and x minus 2. This guy is only missing the x minus 2 piece, so I'll need to do that to the top and to the bottom. Multiplying across, I have 3 times x minus 2 on top and my common denominator on the bottom. Now we'll go ahead and work out my second fraction. I already factored the denominator, finding it to be x minus 2, x minus 1. My goal denominator is x minus 1, x minus 1, x minus 2. This has an x minus 2 and a single x minus 1, but it needs another x minus 1. So I'll multiply the bottom by x minus 1. Whatever I do to the bottom, I must also do to the top to keep things balanced. When I multiply straight across, 1 multiplied by x minus 1 is just x minus 1. Finally, before I actually do the addition, I'm going to go ahead and distribute this 3 in the numerator just to make my life a little bit easier on the next step. This is the same as 3x minus 6 over my same old common denominator. Now that I've built my two fractions up to have the same denominator, I'm going to actually do the addition. So this is 3x minus 6 over my common denominator plus x minus 1 over that same common denominator. They have the same denominator, so I can just add the numerators. 3x minus 6 plus x minus 1 all over that same common denominator. Finally, I should simplify this as much as I can. My numerator has some like terms that can be combined, giving me 4x minus 7 over my same common denominator. Now I look at my numerator and notice that it can't be factored, so this is as simplified as it gets. However, you might notice that a problem like this could be written as 4x minus 7 over x minus 1 squared times x minus 2, because that term is repeated. Either one of these is acceptable for your final answer. That's the end of the section 6.2 video. Now, you've noticed that these problems can take up a lot of space, so make sure that you've got plenty of paper and a nice sharp pencil when you start on your homework.